Assalamualaikum and good afternoon everyone. So in this video we will learn chapter 2, Kinematics of Linear Motion. So we will learn 2.1 and 2.2 only. Okay, so 2.3 we will learn in next video. Okay, so we will learn only linear motion and uniformly accelerated motion. Okay, so before we go through this chapter, maybe we can revise some of terms used in this chapter. Okay, first is distance. The symbol is D or S, and the SI unit is meter. And then displacement, the symbol is S, and the SI unit is meter. So what is the difference between distance and displacement? Distance is a scalar quantity and displacement is vector quantity. Okay, just so you know, scalar quantity has only magnitude, but vector quantity have both magnitude and direction. Okay, and then initial speed. Okay, initial speed, the symbol is U and the unit is meter per second. Okay, the SI unit is meter per second. The final speed symbol is V and the SI unit is meter per second. And then initial velocity, the symbol is also U and the SI unit is also meter per second. And then final velocity, the symbol is V, okay, small letter V, and the SI unit is meter per second. So what is the difference between speed and velocity? Speed and velocity. Speed is a scalar quantity and velocity is vector quantity. Okay, speed is scalar quantity and velocity is vector quantity. Okay, so when it comes to velocity or any vector quantity, we have to consider about the direction. Okay, so the direction might be to the right or to the left or upward or downward. So if the direction is to the right, so it is positive, and if we move to the left, okay, so it is negative. Okay, it has negative sign. And then if it move upward, so it is positive, and if it move downward, it is negative. The same goes for displacement. Okay, displacement also vector quantity. When you come to vector quantity, you have to consider about the direction. Okay, you have to consider about the direction. To the right and upward is positive. To the left and downward is negative. Alright. Okay, and then time. Okay, the symbol for time is small letter t and the SI unit is S. Okay, second. And then the last one is acceleration. Okay, the symbol for acceleration is A and the SI unit is meter per second squared. Alright. Okay, now we want to learning outcome 2.1a, define instantaneous velocity, average velocity, and uniform velocity. Okay, so the definition of instantaneous velocity is rate of change of displacement, okay, at particular time. So this is the instantaneous velocity, okay, rate of change of displacement at particular times. Okay, in formula, V instantaneous equals to ds over dt, okay, where d is change. Okay, when it comes to rate, that means you have to divide with time t. Okay, and then what is the definition of average velocity? Average velocity is the rate of change of displacement. Okay, so the formula is V average, Okay, so AV stand for average. V average equals to delta S over delta T, where delta S is S final minus S initial. Okay, where S final is the symbol of final displacement. Okay, SF is the final displacement. Okay, final displacement. And SI, okay, as SI is symbol for initial displacement. Okay, initial displacement. Right, initial displacement. And TF is the final and TI is the initial. Okay, so this is the definition of average velocity. And then uniform velocity. Uniform velocity is constant velocity. Okay, uniform velocity means constant velocity. That means the velocity is uniform. Okay, it has no change in speed. Okay, the velocity is the same. Okay, the velocity is the same at any time. Okay, or maybe at the range of time the velocity is the same. Okay, maybe at t0 the velocity is 5 meter per second, and then at t1 to t2 until t15 second, the velocity is still 15 meter per second. That means the object move in uniform velocity, or we can say that the object move in constant velocity. Okay, or in other words, the acceleration of the object is 0. Okay, it has no change in velocity. Okay, velocity which is not changing with time, either in magnitude or direction. Okay, in space. So V, when object move in uniform velocity or constant velocity, so V instantaneous will be equals to V average. Alright. And then the next definition is for instantaneous acceleration. Instantaneous acceleration is the rate of change of velocity at particular time. So the formula is A instantaneous equals to dv over dt, or dv here is the change of velocity. Okay, and then next is the definition of average acceleration. Average acceleration, okay, average acceleration is rate of change of velocity, or in formula it is equals to v final minus v initial over time interval, or change in times. Okay, so v final is the symbol of final velocity, and v initial is symbol for initial velocity. Sometimes we can write the initial velocity as u. Okay, the symbol is u. And sometimes for v final, we only write v. Okay, small letter v. Okay, so either you write down u for the symbol of initial velocity, or vi. And then for final velocity, either you write V or VF. Okay. Alright. And then next is definition of uniform acceleration. Uniform acceleration is, okay, uniform acceleration occur when the magnitude of velocity changes at constant rate. Okay. So uniform acceleration occur when the magnitude of velocity changes at constant rate. Okay. So A is uniform. That means it change the speed or velocity at constant rate. Okay. Okay. That means it still have change in speed. It still have change in velocity, but in constant rate. Okay. Okay, next we want to discuss learning outcome 2.1b. Discuss the physical meaning of displacement against time graph. Okay, we have three types of graph, which are displacement against time graph, velocity against time, and acceleration against time. Okay, so the first graph is displacement against time. Look at this title. Okay, y-axis is the displacement. The symbol is S. S is symbol for displacement. So this one is graph of displacement against time graph. Okay. And the y-axis is T. Time. Time in second. Okay. Basically we write like this. Time and then bracket the unit second. Okay. And then the second one is graph of velocity, okay, against time. Look at this axis. This is velocity v in unit, velocity v in unit meter per second. And then the x-axis is the time t, okay, time t in unit second. So this one is graph of velocity against time. Okay, and then the third one is, look at this y-axis. This is the acceleration. Okay, the symbol is A here. Okay, so this is A, acceleration in unit meter per second squared against x-axis. The x-axis is time t, right? And the unit is second. Okay, so we have these three types of graph in this chapter. Okay, displacement against time, velocity against time, and acceleration against time. Okay, so okay, when you have a graph, you have to look at the y-axis and x-axis first and their units. Okay, this is very important to identify what kind of graph. Okay. Okay, for this one, okay, we have this shape of graph. Okay, displacement against time like this. Okay. So gradient of graph of displacement against time. Okay, gradient of graph of displacement against time represent the velocity. So this is curve graph. That means it has, okay, for this area the gradient is increased, right? Look at this area. Okay, at this area the gradient is increased, right? So that means velocity increase, because gradient of displacement against time represent velocity. So in this area velocity is increased as well. So how do you find the value of velocity? It is from the gradient of displacement against time. And then at this area the gradient is constant. Gradient of displacement against time at this area, okay, part 2, the gradient is constant. That means the velocity is constant as well, right? And then at this area, okay, the gradient, okay, maybe you can sketch the what we call this, you can sketch the tangent, okay, initial and final at this part 3. Okay, as you can see here, okay, the gradient is decreased, right? The gradient is decreased, so velocity will be decreased as well, like this. Okay, and then at this area, okay, velocity decrease. Alright, and then for this one, gradient is decrease. Okay, gradient decrease as well, but look at this shape. Okay, displacement is increases from maybe 120 here to 40 meter, right? So that's mean this object move in opposite direction. Okay, this object move in opposite direction. Okay, maybe I can illustrate the motion and meter rule like this. Okay, this is meter rule. This is displacement 0, and then 1, 2, 3, 4, whatever number here increases, right? Okay, maybe 160 like that. Okay, as 160 meter here. Okay. Okay, from the graph of displacement against time at t0, the object is at displacement 0, right? At this point, and then at t5 second, okay, it already moved to the 40 meter, right? Okay, so this is part 1. Part 2, it is still moved to the 80 meter. Okay, part 2, part 3 also increases until part 3. Okay, it still move to the 160 meter. Okay, for time t0 to time t15 second. Okay, so the object move to the right, right? And then after t 15 second, is it 15 or 16? 15, right? Okay, at t 16 second, after t 15 second, okay, after t 15 second, the displacement decrease to 120. 120 is in this area, right? So that means the object move in opposite direction, or we can say it move to the left. Am I right? Move to the left. Okay, and then it still decreases. Okay, in this area, 60, 40, and then until the last part. Okay, 6, right? Okay, part 6, it is at this area. It is static at 40 meter. Okay, so dia tak sampai 0 lah. Okay, tak sampai 0, maybe at this area 40 meter. Okay, okay, and it's static here. Okay, so that's mean part 1, 2, 3, 4, 5, 6. Part 6. Okay, part 6, the object is at rest. It doesn't move. Okay, it's static at displacement 40 meter. Alright. So for displacement, you can illustrate or you can imagine it move on a ruler. Okay, on a ruler. Okay, like this. Okay, so for part 4, it is the gradient, the part 4, for the part 4, the gradient is decrease. The gradient decrease or increases. Okay, let us check again. Okay, part 4. Okay, this is the tangent. Oh, okay, the gradient is increased, right? The gradient is increased, so the velocity is increased, but the direction is to the left or move to opposite direction. Okay, look at this area. This is part 4. Okay, so velocity here is from 0 to 20. Okay, so that's mean it is increasing the speed, but negative 20 mean it move to the opposite direction. Okay, this is not scalar. Okay, this is not scalar. Negative 20, you have to, okay, consider like this. Negative 20 meter per second. The speed is 20 meter per second. Okay, the negative is the direction. Okay, negative is direction to the left, and 20 meter per second is the speed. Okay, that means the speed at this area, at area 4. Okay, area 4, it increases from 0 to 20, and then it is negative because the direction is to the left. Okay, direction is to the left. And then part 5, this one, part 5. Okay, look at the gradient. Okay, look at the gradient here. You may sketch tangent at this area, and then this. So the tangent is, the gradient is decrease, right? The gradient is decrease. So the velocity also decrease from 20 to 0. Okay, from 20 to 0. Okay, negative means the direction is to the left. Okay, so it still move in opposite direction at part 5. And then at area 6 here, area 6, it does not move. It does not move. Okay, it is static at displacement 40 meter. Okay, does not move. Okay, so gradient of velocity against time gradient of displacement against time represent velocity, and gradient of velocity against time graph represent acceleration. Okay, gradient of graph velocity against time represent acceleration. Okay, so how you can determine the acceleration? Of course, it is from the gradient of the velocity against time graph. Okay, so the gradient is always constant. Okay, so you can transfer to the graph acceleration against time. Alright, and one more thing is area under the graph. Okay, area under the graph of velocity against time represent the displacement. Okay, so in this area, okay, maybe I can clean up all this first. Okay, so this one is positive displacement. That means it moves to the right. Okay, and this area, the object move in opposite direction or to the left. Okay, so when object move to the right, okay, the displacement is positive. When object move to the left, it is negative. Okay, so this area, maybe this is displacement 1, and then this is displacement 2. For displacement 1, it is positive because it's moved to the right. Okay, like this. And then for displacement 2, it is negative because it moved to the left. This one is for displacement. But if the question asks you the distance traveled by this object, so you have to only add S1 plus S2, because for distance you don't have to consider about the direction. But for displacement, okay, you have to consider about the direction. For when it moves to the left, so it has negative sign. So when it moves to the when it moves downward, so it has negative direction. Alright, so this is the graph of acceleration. Okay, so the value of acceleration can be obtained from the gradient of velocity against time. Okay, directly from the gradient of velocity against time. Okay, I hope you can understand these three graphs. Okay, when you get a graph, okay, so first thing you have to do is to identify what kind of graph is that. Okay, so look at the y-axis, the title of the y-axis and the unit first. Okay, and then for displacement against time graph, maybe you can illustrate, okay, a meter ruler like this, okay. Then you can imagine, okay, so the object move to the right or to the left, okay. Okay, so this is the explanation for part 1. The object is moving from origin, okay, with increasing speed. How do you know increasing speed? Because the gradient is increase, okay. Gradient increase means speed increase, okay. And it move to the positive direction, okay, v increase and a is constant. And for the part 2, the object is moving, okay, is moving still from the origin with constant speed, okay, part 2, okay, positive direction, v and v constant, okay, in this area, v constant, okay, because the gradient here is constant. This is curve graph, okay, for part 1 is curve graph. So gradient increase, speed increase. And then part 2, gradient constant, so speed constant here, okay. Okay, again, okay, this is part 1. Part 1, curve graph, gradient increase, right, so speed increase. And then for part 2, gradient constant, so speed constant, okay. And then for part 3, okay, this is part 3, the gradient is, maybe you can draw tangent here, okay, the slope is decreased, right, the slope is decreased, so gradient decrease, that means the speed is decreased as well. Alright. And then for part 4, the gradient, okay, the gradient is increased. For part 4, gradient is increased. Look at the tangent, okay, the slope is steeper, right, the slope is steeper, that means the gradient increase, so that means the speed also increase from 0 to 20. 0 to 20. Like I mentioned earlier, the negative sign here is meant for direction, okay, move to the left, okay. And then for part 5 here, the gradient is decrease, okay. So the gradient decrease, that means the speed decrease from 20 to 0, okay, from 20 to 0. And then at part 5, okay, the gradient is 0, so velocity is 0. It doesn't move at part 5. Sorry, part 6. It doesn't move at part 6. Okay, so this is the explanation. Okay. Okay, part 6, the object is stationary. It does not move. Alright. Okay, so this is the example. One of question. Okay, the distance of a car travel along a straight road is given as this: x equals 1.5 t squared plus 0.3 t cubed. Okay, determine the average speed of the car for the time interval t0 to t6 second. Okay, so what is the formula for average speed? So for average velocity, it is v equals ds dt. Sorry, v equals to this one, s final minus s initial over time interval. So for speed, you can determine the distance. Okay, so distance okay, you may substitute for t0. Okay, when t0, what is the value of distance? It is from x. Okay, just substitute t0 into this equation, then you can determine the distance at t0. Okay, so at t0 the distance is 0, and then when t 6 second, okay, t6 second, substitute t6 second into this equation, x equals to 1.5. Just substitute t6 second, this squared here, okay, plus 0.3 times 6 cube, so the value is 118.9 meter. Okay, then you can use that formula. Okay, this formula, V average. Okay, so speed average equals to distance final. Okay, distance final minus distance initial per time interval. Okay, so 118.9 minus 0 over 6 minus 0. So the average speed is 19.8 meter per second. Okay, next B, the instantaneous velocity of the car at t5 second. Okay, so you are given the equation of distance. So you can get the velocity or speed, okay, when you differentiate equation x. So V equals to, this one is for question B. Okay, you can determine V when you differentiate x. V equals to dx dt. If the symbol is s, you can differentiate s. V equals to ds over dt. Okay, remember how to differentiate. Okay, so 2 times 1.5 equals to 3. Okay, and then 2 minus 1, okay, t, and then 3 times 0.3 equals 0.9, and then t squared. Okay, so this is the equation of V, right? So this is the equation of V. So what you should do, you only can you just substitute t equals 5 seconds into this equation. So V equals to 3, just substitute T5, okay, 0.95 squared. So V equals to 37.5 meter per second. Alright, okay. So this is question number 1A and B. Okay, and then maybe you can try for question number 2 and number 3. Okay, for number 2 we are given the graph of S against T, and the S in unit cm and T in unit second. So be careful with the unit. Okay, and then question 3 will also be given graph. Okay, but this one is graph of velocity V in unit meter per second against time t in unit second. Okay. Okay, now we can proceed to 2.2, uniform decelerated motion. Okay, uniform decelerated motion. Okay, so in this learning outcome, okay, it only apply equation. Okay, for this subtopic, okay, the learning outcome is only apply equations of motion of the uniform acceleration. So the equation will be given. Okay, the 4 equation will be given. Okay, for extra information, we want to derive these 4 equation. Okay, we want to derive the 4 equation. Okay, the first thing is from this concept. Okay, from this concept, acceleration equals gradient of the graph. Okay, acceleration equals to gradient of the graph. So gradient of the graph, okay, okay, this point and this point. Okay, so y2 minus y1 over x2 minus x1, where y2 is v and y2 is u. Alright, and x2 is t and x1 is 0. So we have this one. A equals to v minus u over t minus 0. So arrange this equation. Let v be the subject. So v equals u plus at. Now we have first equation. Okay, first formula. V equals to u plus at. And then the second equation is still from the graph. Okay, just so you know, the area under the graph of velocity against time represent the displacement. Okay, represent the displacement. Okay, area under the graph represent the displacement as equals to area under the graph, right? As equals to area under graph of v against t. So look at this shape. Okay, so this is the shape of trapezium, right? So the formula of trapezium is half plus, okay, both parallel sides, okay, additional of parallel sides, okay, times the height, right? So this is parallel u and v. Okay, this height is u and this height is v. So we have s equals to u plus v and then times height t. Okay, so equation 2 come from the concept of displacement equals to area under the graph of v against t. So the shape is trapezium. Start from initial velocity u and final velocity v in times t. So we have s equals to half u plus v times t. And then the third equation, okay, come from equation 1 and 2, where we substitute equation 1 into equation 2. We substitute v equals to u plus t, v equals to u plus at into equation s equals half u plus v times t. Okay, so substitute. Okay, let me show you. S equals to half u plus v times t. Okay, this is the equation 2. So you substitute equation 1, but equation 1 is v equals u plus t. So substitute v in terms of u plus at times t, right? Okay, simplify. U plus u equals to u, okay, and then at times t. Okay, then simplify. Half times u equals to u, and then times t, you get ut, and then half times at times t equals to at squared. Now you get the equation, the third equation. Okay, equation 3, s equals to ut plus half at squared. Okay, now the last equation, okay, v equals to u squared plus 2as. Okay, how you get this equation? It is from equation 1 and equation 2. So from equation 1, okay, okay, we arrange equation 1. Let v minus u be the subject. V minus, okay, we bring u to the left hand side. Okay, equation 1 is 1. Okay, we bring u to the left hand side. So v minus u equals to at. So this is equation 1. Okay, we arrange equation 1. And then from equation 2, okay, we bring v plus u to the right to the left hand side. Okay, this is equation 2 like this. Alright, so okay, we arrange, maybe we bring 2 to left hand side first. 2s equals to u plus v times t, right? Okay, and then let u plus v be the subject. Okay, u plus v times t equals 2s. So u plus v equals 2s over t. Alright. You also may write like this: v plus u equals to 2s over t. So this is the equation 2. Okay. V plus u equals to 2s over t. This is equation 2. And then what we do is we multiply. Okay, multiply equation 1 with equation 2. Equation 1 that we arrange, then equation 2 that we arrange. Alright. So left hand side equation 1 times left hand side equation 2 equals to right hand side equation 1 times right hand side equation 2. And then simplify this equation. Okay, like this. So it become v squared minus u squared, right? And then for this one, it become, okay, t and t will be cancelled. So you got 2as, right? And then let v squared be the subject. So v squared, okay, bring u squared to the right hand side. So u squared plus 2as. So you get the fourth equation. Okay, so it is easy. Okay, so for the video of projectile motion, okay, for subtopic projectile motion will be in next video. Okay, that's it for this time. Thank you, class. Bye.